Okay. So next is the relationship between the zeros and coefficient of a polynomial. Okay. Zeros and coefficient of a polynomial. So first we have to consider linear polynomial. So anybody have any doubt with the graphical representation? So I will explain once. So, okay. So I will explain once more. So graphical representation of linear polynomial. Okay, Dekshit. Okay, I'll explain it once again. So here we take a linear polynomial y is equal to 2x plus 3. Okay. And for linear representing linear polynomial, just take only 2 points. Take x equal to 0 and 1. Okay, x equal to 0 and 1, and put the value of x in this equation, that is in this equation, and we get the corresponding value of y. So if x equal to 0, then y equal to 3, and x equal to 1, then y is equal to 5. So we get 2 points, and plot this 2 points on this graph. Okay, so first for x equal to 0, the corresponding point is here. Okay, 0, and the corresponding y coordinate is 3, and for x equal to 1, the corresponding y coordinate is 5. Here 1, 5, and join this 2 lines, these 2 points, and we get a straight line. So the shape we achieved from a linear polynomial Okay, can you see the screen? Can you see the screen? The PPT? Okay. Okay. I will stop share and try it one more. 1 second. Is it okay now? Is it okay? Okay, good. So we take the linear polynomial 2x plus 3, and we take 2 values for x and y. Can you see it as a slideshow? Just check if it is moving. Can you see? Okay, what's happening? 1 second. Is it okay now? Okay, good. So where we stop? The graphical representation of linear polynomial. So the linear polynomial is 2x plus 3, and we take two values for x and y. First, we take for values for x as 0 and 1. Then the corresponding y value is, y coordinates is 3 and 5. And we plotted this on the graph and we connected it as a straight line. We get a straight line here. Okay. And we extended this straight line to the x-axis. We extended this straight line to the x-axis, and where this line intersect on the x-axis, the point where the line intersects on the x-axis, that point, that corresponding x coordinate is the zeros of the linear polynomial. Here it is minus 3 by 2 because here it is in between minus 1 and minus 2. That is minus 1.5, which is minus 3 by 2. Okay. So here the x coordinate of that corresponding point is minus 3 by 2, which is the zeros of the polynomial 2x plus 3. Okay. And similarly, for quadratic polynomial, we should take more than 2 points. So take minus 2, minus 1, 0, 1, 2, 3, 4, 5. And the corresponding y coordinates, put this values of x in this equation and find the corresponding y coordinate and plot these points on the graph like linear polynomial, and we get a shape like, when we put the coordinates on the graph and we get a shape like parabola. The shape is called parabola, and the points where this parabola touches on x-axis, that is the points where this line, this parabola intersects on x-axis is minus 1, 0 and 4, 0. Okay, minus 1, 0 and 4, 0 is a line intersect on x-axis. And the corresponding x coordinate in that line is minus 1 and 4. So these are the zeros of the polynomial x squared minus 3x plus 4. So these are the zeros of the polynomial x squared minus 3x plus 4. Okay, is it clear, Dakshit, now? Is it clear, Dakshit? Okay, okay, good. So moving to the next, which is, so this is two exceptional cases. If it is complete, this parabola is completely above or below x-axis. If it doesn't touches the x-axis, then the polynomial has no zeros. Okay. So next is the relationship between zeros and coefficient of a polynomial. So if we considering a linear polynomial, first a linear polynomial, then we should go for an example. If the polynomial is p of x is equal to 2x plus 5, then how can we find the zeros? Equate p of x is equal to 0. That is 2x plus 5 is equal to 0 and x is equal to minus 5 by 2. So what is minus 5 here? Minus 5 is the minus of constant. 5 is the constant in this equation, right? And 2 is the coefficient of x. So minus constant by coefficient of x is the zero of the polynomial. So here the zeros of the polynomial in the linear polynomial is equal to what? Minus of the constant coefficient divided by coefficient of x. So that is the zeros of the linear polynomial. That is the relation of zeros and coefficient of a linear polynomial. Okay. Moving to the quadratic polynomial. So we should consider a quadratic polynomial, that is 2x square minus 8x plus 6. Okay, 8x plus 6. So, do you remember the method to finding the roots of this quadratic polynomial? If it is equal to 0, then split the middle term, splitting the middle term. Then we get 6 into 2 is equal to 12. And the middle term is minus 8. We want two numbers, A and B. AB should be equal to 12 and A plus B should be equal to minus 8. And we should find minus 2 into 6 is equal to 12 and minus 2 plus 6 is equal to, sorry, minus 2 minus 6. Minus 2 minus 6 equal to minus 8. Okay, and minus 2 and minus 6 is the numbers. And 2x square minus 2x. Here we can write minus 2x plus 6. Okay, then combine this two terms and combine these two terms. Here, first factorize the first term, that is 2 into x minus 3 into 2 into x. So we can combine 2x from here and 2x from here. That is 2x into x minus 3. For first, that is 2x into x minus 3 minus the next portion 2 into x minus 3 into 2. And you can take 2 as common, 2 into x minus 3. When we multiply this negative symbol to here also get negative, and 2 into x minus 3. Okay, so what are the factors? 2x minus 2 and x minus 3 is equal to 0. Okay, so first one is 2x minus 2 is equal to 0 and second one is x minus 3 is equal to 0. From here, x is equal to 1 and here x is equal to 3. So we get two values for x, that is 1 and 3. And now x is equal to 1 and 3. We can take it as alpha and beta. Alpha is equal to 3 and beta is equal to 1. So if the sum of the zeros, if we are calculating the sum of zeros, that is alpha and beta. That is alpha plus beta is equal to, what is here? 4. We can relate it to the coefficients as, which is equal to minus coefficient of x divided by coefficient of x square. So let us check what is the coefficient of x here, which is equal to minus 8. That is minus coefficient of x means minus of minus 8 divided by coefficient of x square is 2. So the answer is 4. So here also we get answer 4 and here also we get the answer 4. That is sum of zeros alpha plus beta is equal to minus coefficient of x by coefficient of x square. That correct table, that is b by minus b by a. If the equation is ax square plus bx plus c is equal to 0, then sum of zeros alpha plus beta is equal to minus b by a. Next is product of zeros. Product of zeros is equal to alpha beta. Here it is 3, and which is the constant divided by coefficient of x square. That is, what is constant here? 6 divided by 2. That is 3. Again, the answer is same. So, the product of 0 alpha beta is equal to C by A. So, this is the relation of zeros and coefficient of a quadratic polynomial. And finally, for a cubic polynomial, second. Okay. So I'll write it here. For cubic polynomial, if the equation is for cubic polynomial, if the equation is ax cube plus bx squared plus cx plus d. If this is the equation, then what is the relation between zeros and the coefficient? If we take alpha, beta, and gamma are the zeros, then alpha plus beta plus gamma is equal to minus b by a, and alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus d by a. So this is the relation of zeros and coefficients of a cubic polynomial. Okay. So these are the relationship between zeros and coefficient of linear polynomial, quadratic polynomial, and cubic polynomial. Okay. Clear? So these are all are the concepts covered in this chapter. And shall we move to the questions? Okay. So look at the first question. One more question. That is zeros of a polynomial. First question. The zeros of a polynomial P of y is dash of the point where graph intersect the y-axis. So what is the zeros of a polynomial P of y? P of y? No, I think cubic polynomials is also there. Not important as quadratic and linear, but I think that it's not deleted. Okay. Okay, Shiza. So zeros of a polynomial P of y dash of the point where graph intersect y-axis. Okay. So the answer is, we call it as ordinate. Ordinate of the point. Okay. So what is ordinate? We already studied that ordinate and abscissa. So for consider P of xy. Okay. In P of xy, for example, P of 2, 3. For this, the first x-axis, the number on the x-axis is the abscissa, and coordinate on the y-axis is the ordinate. Okay. So these are abscissa and ordinate. So here zeros of a polynomial P of y is ordinate of the point where graph intersect y-axis. Okay. Next is the pair of zeros of the polynomial 2x square plus 4x plus 20 is equal to. So in this question, you just find the zeros of the polynomial, this polynomial, the quadratic polynomial, 2x square plus 4x, 14x plus 20. Okay. So the second question, we have to find the zeros of the polynomial 2x square plus 14x plus 20. Okay, 2x square plus 14x plus 20. That is p of x is equal to 2x square plus 14x plus 20. Then here also the method is splitting the middle term. Just split the middle term and the remaining terms 20 into 2 is equal to 40 and the middle term is equal to 40. So the number should be a into b is equal to 40 and a plus b should be equal to 14. So what will be the numbers? Just factorize the number 40. Okay, 2, 20, 2, 10, 2, 5. So just check 4 and 10. 4 and 10. So 4 into 10 is equal to 40 and 4 plus 10 is equal to 40. Okay. So we can take 2x square plus 4x plus 10x plus 20. Okay. Correct table 10 and 4. And just take two pairs. First one is 2x square plus 4x. 2x square plus 4x. That is 2 into x plus 2 into x. So we can take 2 and x as common from both sides. That is 2x into x plus 2. Okay. So this can be written as 2x into x plus 2. Plus next terms are 5 into 2 into x plus 10 into 2. So we can take 10 as common. That is 10 into x plus 2. That is 10 into x plus 2. So rearranging it, 2x plus 10 and x plus 2 is equal to 0. So 2x plus 10 is equal to 0 and x plus 2 is equal to 0. Okay, so here x is equal to minus 10 by 2, that is minus 5, and x is equal to minus 2. So what are the zeros of this polynomial? Zeros are minus 5 and minus 2. Okay, clear? So moving to the next question. Third question, if one of the zeros of the cubic polynomial, okay, one of the zeros of the cubic polynomial x cube plus 2ax square plus bx plus c is minus 1, then the product of other two zeros is, okay, so one of the zero is minus 1. Okay. Question 3. We have a cubic polynomial here, x cube plus ax square plus bx plus c. It's a cubic polynomial. Here a is equal to 1, b is equal to a, comparing to the standard form. That is ax cube plus bx square plus cx plus D. So A is equal to 1 here, B is equal to A, and C is equal to B, and D is equal to C. Okay, and one of the 0 is -1, which is given in the question. So 3 zeros are the alpha, beta, and gamma. So let gamma is equal to -1. Okay, then we know that the relation alpha plus beta plus gamma is equal to -b by a. So here alpha, we don't know alpha and beta, but gamma is -1, which is equal to, here b is a. So minus a by, and a is 1 here. Okay, so minus a by 1. Okay, that is, which implies alpha plus beta is equal to minus a plus 1. So take it as equation 1. And take the next relation, that is alpha beta plus beta gamma plus gamma alpha is equal to, we know that it is C by A. Okay, so here C is B and A is 1 and gamma is -1. So which implies alpha minus gamma, sorry, alpha minus beta minus alpha beta minus beta minus alpha. Okay, alpha beta minus alpha is equal to, here C is B and A is 1. So which is equal to B. Okay, and we can rearrange it as, that is alpha beta, and next alpha beta, the relation alpha beta is equal to, one second. So from here alpha beta is equal to B plus alpha plus beta. Okay, so from here alpha beta is equal to, we are taking this values to the right hand side. So alpha beta is equal to B plus alpha plus beta. Okay, take this as equation 2. Okay, so from equation 1, we know that alpha plus beta, this portion is minus a plus 1. Is it? So we can rewrite it as alpha beta is equal to b minus a plus 1. So this is the answer. What's our question? Product of other two zeros. One of the zero is gamma. We take it as -1. And what is the product of other two zeros? What are the other two zeros? Alpha and beta. The product of other two zeros are b minus a plus 1. Therefore, product of other two zeros are alpha beta is equal to b plus a minus 1. So this is the, sorry, b minus a plus 1. This is the answer. Clear? Any doubts? So we have a cubic polynomial here, and one of the zeros is given. We take it as gamma. Gamma is equal to -1, and we have the relation alpha plus beta plus gamma is equal to minus b by a. Here b is a and a is 1. Substitute the values. Then we get alpha plus beta minus 1. That is gamma is -1 is equal to minus a. And from that we get alpha plus beta is equal to minus a plus 1. And the second relation alpha beta plus beta gamma plus gamma alpha is equal to c by a, which implies alpha beta minus beta, because gamma is -1 minus alpha is equal to b, because c is b here in this polynomial. So, which is equal to b, and from that, we rearranging the equation, we get alpha beta is equal to beta plus alpha plus beta. We take it as equation 2, and we know that alpha plus beta is minus a plus 1 from the equation 1, and substituting that equation, that value to equation 2, we get alpha beta is equal to b minus a plus 1. So that is the product of other two zeros, that is alpha into beta, which is equal to b minus a plus 1. Okay, clear? So moving to the next set of questions, 2 mark questions. If a plus c plus e is equal to 0, okay, if a plus c plus e is equal to 0 and b plus d is equal to 0, then find the zeros of the polynomial ax raised to 4 plus bx cube plus cx square plus dx plus e is equal to 0. Okay. So, first we have to write the polynomial. So, what is the polynomial here? P of x is equal to ax raised to 4 plus bx cube plus cx square plus dx plus e. So, this is the polynomial, and first we have to put x is equal to 1. That is p of 1. What is the value of p of 1 here? That is a plus b plus c plus d plus e. Okay. And rearrange the values. That is a plus c plus e plus b plus d. So look at the question. In the question it is given that a plus c plus e is equal to 0 and b plus d is equal to 0. Okay. A plus c plus e is equal to 0 and b plus d is equal to 0, which is given in the question. So look at here. This is a plus c plus e, which is equal to 0, plus b plus d is again is equal to 0. That is 0 plus 0 is equal to 0. That is p of 1 is equal to 0. So that is at x is equal to 1, p of x is equal to 0. That is x is equal to 1 is the 0 of the given polynomial. That is x is equal to 1 is the 1, 0 of the polynomial. Okay. So now put x is equal to minus 1. X is equal to minus 1. Then p of minus 1. What is p of minus 1 here? That is a into minus 1 raised to 4 plus a into minus 1 cube plus, sorry, a not b. C into minus 1 square plus d into minus 1 plus e. So this will be a minus b plus c minus d plus e. So again rearranging a plus c plus e. Then take minus as common, then minus of b plus d. Okay. So again a plus c plus e is 0 minus b plus d is 0. So 0 minus 0 is 0 again. So that is at x is equal to minus 1, x equal to minus 1, p of x equal to 0. So x is equal to -1 is the another zero of the polynomial. Okay. So what are the zeros of this polynomial? Therefore, zeros of the polynomial p of x is equal to 1 and -1. Okay, clear? So moving to the next question. Find the zeros of the following quadratic polynomial and verify the relationship between zeros and their coefficient. So first you should find the zeros of the quadratic polynomial and then you have to verify the relation between zeros and the coefficient. Okay. So first we have to find the zeros of the polynomial. So the question number 2. The polynomial p of y is equal to 7y square minus 11 by 3y minus 2 by 3. Okay. So from this, we can take minus 1 by 3 as common. So taking 1 by 3 as common, here we get 21y square minus 11y minus 2. That is here 7 divided by 1 by 3. That is equal to 7 into 3 is equal to 21. Okay. And take 1 by 3 as common from this equation and split the middle term 11 minus 11y. So AB should be 21 into AB should be 21 into minus 2, which is equal to minus 42. And A plus B should be equal to minus 11. So what will be the numbers? Just factorize 42 to 21, 7, 3. So we can take 7 into 2, 14. Just check 14 and 3. 14 and 3. So we have negative symbol here. So try minus 14 and 3. Okay. Minus 14 into 3 is equal to minus 42 and minus 14 plus 3 is minus 11. So the values are minus 14y plus 3y minus 2. Okay, into 1 by 3. So again, pairing this and this, we get 1 by 3 into 7y plus 1 into 3y minus 2. Okay, 7y plus 1 and 3y minus 2. So, which is equal to, multiply this 1 by 3 to this equation, we get, we can rearrange it as 1 by 3 into 3y minus 2 into 7y plus 1. And here it is 3 by 3 is equal to y minus 2 by 3 and 7y plus 1. Okay. So here y minus, which implies y minus 2 by 3 is equal to 0 and 7y plus 1 is equal to 0. And the zeros are y is equal to 2 by 3 and y is equal to minus 1 by 7. So the zeros are 2 by 3 and minus 1 by 7. Now we have to verify it with the relation. Okay. So to verify, that is sum of zeros. Here alpha and beta. Alpha and beta are minus 2 by 3 and 2 by 3 and minus 1 by 7. Okay. So sum of zeros is equal to 2 by 3 plus minus 1 by 7. It is 2 by 3 minus 1 by 7, which is equal to 14 minus 3 divided by 21. That is equal to 11 by 21. And from equation, we know that sum of zeros is equal to minus of coefficient of y divided by coefficient of y square. So minus of coefficient of y is minus 11 by 3, minus of minus 11 by 3 divided by coefficient of y square, that is 7. So which is equal to 11 by 3 by 7 is equal to 11 by 21. So equation 1 is equal to equation 2. 1 is equal to 2. Verified. And next is product of 0. Product of zeros is equal to 2 by 3 into minus 1 by 7. Okay. And which is equal to minus 2 by 21. And by formula, product of zeros is equal to constant divided by coefficient of y square. So here constant is minus 2 by 3 divided by 7, which is equal to minus 2 by 20. So again, 3 is equal to 4. 3 is equal to 4. So verified. Okay. So next is, if the zeros of the polynomial x square minus px plus q are double in value to zeros of 2x square minus 5x minus 3. So find the value of p and q. So here, the question is given that, question number 3. That is, the polynomial given is 2x square minus 5x plus 5x minus 3. That is, p of x is equal to 2x square minus 5x minus 3. The question, it is given that if the zeros of the polynomial x square minus px plus q are double in value to this polynomial, that is 2x square minus 5x minus 3. So now we have to find the zeros of this polynomial. Zeros of 2x square minus 5x minus 3 is equal to 0. Then splitting the middle term, we get the values minus 6x plus x, 2x square, and combining this and this, we get x minus 3 into 2x plus 1 is equal to 0. And the zeros are x is equal to 3 and x is equal to minus 1 by 2. So x is equal to 3 and x is equal to minus 1 by 2 are the zeros. Now in the question, it is given that zeros of x square minus px plus q are double in value of zeros of this polynomial, that is 2x square minus 5x minus 3. So the zeros of this polynomial is x equal to 3 and x equal to minus 1 by 2. Then what will be the zeros of x square minus px plus q? Zeros of x square minus px plus q, which is the double of the zeros of 2x square minus 5x minus 3. So, the zeros are 6 and minus 1. Double of 3 and 1 by 2. That is 6 and minus 1. And then we can write, take it as alpha and beta. Then alpha plus beta, the sum of zeros is equal to minus b by a. Is it? So here, this is a and this is b and this is c. So alpha plus beta is equal to minus b by a. That is 6 plus minus 1 is equal to, what is b here? Minus p by 1. Okay. Because here a is equal to 1, b is equal to minus p and c is equal to q. So minus of minus p. That is p is equal to 6 minus 1, which is equal to 5. The value of p is equal to 5 and then we have to find the value of q. Then next, product of roots, that is alpha beta is equal to c by a. And here alpha beta is 6 into minus 1 is equal to, what is c here? Q. Q by 1 and q is equal to minus 6. And p is equal to, that is p is equal to 5 and q is equal to minus 6. Okay, clear? Any doubt from these questions? So shall we move to the next set of questions? Okay, so very good. So next set of question, 3 more question. Okay, if alpha, beta and gamma as alpha, beta are zeros of quadratic polynomial ax square plus bx plus c. Okay, Asha, good. So alpha, beta are zeros of the quadratic polynomial ax square plus bx plus c. Then find the value of alpha square minus beta square. Okay, so that's our first question. That is, the required polynomial is p of x is equal to ax square plus bx plus c. Okay, so the polynomial is ax square plus bx plus c is equal to 0. And we know that alpha plus beta. What is alpha plus beta here? Sum of the zeros is minus b by a. And alpha beta is equal to c by a. Okay. And if alpha plus beta is minus b by a, then we can take alpha plus beta, the whole square is equal to b square minus by a square. Okay, alpha plus beta, the whole square is equal to b square by a square. And alpha minus beta, the whole square. We can expand it like alpha plus beta, the whole square minus 4 alpha beta. Okay. So we can write it as, we know that alpha plus beta is b square by a square minus 4 into alpha beta is c by a. Okay. So this is b square by a square minus 4c by a. Okay, b square by a square minus 4c by a. And we can write it as b square minus 4ac by a square. Okay. Then alpha minus beta is equal to, what is alpha minus beta? Root of this equation. B square minus 4ac by a square. And taking the root, we get root of b square minus 4ac. Take this term as here and take the root of a, we get a. So alpha minus beta is equal to root of b square minus 4ac by a. And now take alpha square minus beta square. So what is alpha square minus beta square? We can write it as alpha plus beta into alpha minus beta. Okay. So what is alpha plus beta? Alpha plus beta is minus b by a. Minus b by a into alpha minus beta is root of b square minus 4ac by a. Okay. B square minus 4ac by a. Where minus alpha beta, where one second. Oh, okay, okay. Alpha minus beta the whole square, right? Able? One second. Okay. So it is 2ab, right? Sorry. So okay, I will change it. It's 2ab, okay? So we have an expansion like, one second, I have a doubt. Okay, one second, I will clear it. Let me finish it, okay? So here minus b, where we stop? So which is equal to minus b root of b square minus 4ac divided by a square. Okay. So able here is the problem, right? For this equation. This is for a minus b the whole square. The expansion is a square minus 2ab plus b square. Is it? And we combining here a square plus b square. That is, when we combining a square plus b square here, then what is the expansion there? A plus b into a minus b, right? Yeah, okay. So here, separation. So here a plus b is minus b by a. And when we combining that equation, we get the equation a alpha plus beta, the whole square minus 4 alpha beta. Okay. I will explain it in the last, okay. So the next question is, find the quadratic polynomial whose zeros are minus 3 and 2. Okay, Shiza. So our next question is, find the quadratic polynomial. We have to find the quadratic polynomial whose zeros are minus 3 and 2. Okay, minus 3 and 2. So, second question, we have to find the quadratic polynomial. So, we have a formula for that, right? So, the given zeros are minus 3 and 2. Minus 3 and minus 2 are the given zeros. And we have a formula for that. That is P of x is equal to x square minus sum of zeros into x plus product of zeros. Okay, product of zeros. So here we have alpha and beta, that is x square minus alpha plus beta into x plus alpha beta. Okay, so x square minus 3 plus minus 2 into x plus alpha. What is alpha here? Minus 3 into minus 2. So x square minus 5x plus 6. So the polynomial is x square plus 5x plus 6. So this is a polynomial. Okay, moving to the next question. If alpha, beta, the roots of the equation 3x square minus 6x plus 4 is equal to 0, then the value of alpha by beta plus beta by alpha plus 2 into 1 by alpha plus 1 by beta plus 3 alpha beta will be. Okay, so the required polynomial is, the given polynomial is 3x minus 6x plus 4 is equal to 0. So this is the given polynomial. Okay. And we have to find the value of alpha by beta plus beta by gamma. So sum of zeros. Here alpha and beta are zeros of the polynomial, right? Are zeros of the polynomial. Okay. And sum of zeros is equal to alpha plus beta. We know that which is equal to minus b by a. Here it is A, this is B, and this is C. So minus of minus 6 by 3, and the value is 2. And product of zeros is equal to alpha beta, which is equal to 4 by C by A. It is 4 by 3. And now we want to find first alpha by beta plus beta by alpha. That is alpha square plus beta square and divided by alpha beta. So we can expand it like alpha square plus beta square as alpha plus beta the whole square plus minus 2 alpha beta. Okay, we can expand it like alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta and divided by alpha beta. Okay, which is equal to alpha plus beta the whole square. We already find alpha plus beta, which is 2. So this is 2 square minus 2 into, and alpha beta, the value is 4 by 3. Divided by alpha beta, that is 4 by 3. Okay, so the answer is 4 minus 8 by 3 divided by 4 by 3, which is equal to 12 minus 8 by 3 divided by 4 by 3, which is equal to 4 by 3 into 3 by 4 is 1. Okay, and then 1 by alpha plus 1 by beta is equal to alpha plus beta divided by alpha beta. That is alpha plus beta, we know that it is 2 divided by 4 by 3, which is equal to 3 by 2. And now we can put it in the value. Therefore, what is the question? Alpha by beta plus beta by alpha plus 2 into 1 by alpha plus 1 by beta plus 3 alpha beta. So, alpha by beta plus beta by alpha is, the answer is 1. So, 1 plus 2 into 1 by alpha plus 1 by beta is 3 by 2. 3 by 2 plus 3 into alpha beta is 4 by 3. And the answer will be 8, which is equal to 1 plus 3 plus 4. And is equal to 8. Okay. And the next question is, if x square plus 2x minus 3 is a factor of f of x, where f of x equal to x raised to 4 plus 6x cube plus 2ax square plus bx minus 3a, then find the value of a and b. Okay. The second question, f of x is equal to x raised to 4 plus 6x cube plus 2ax square plus bx minus 3a. Okay, so we have to find a and b. Then another polynomial is given. Now x square plus 2x minus 3. It is given as a factor of this polynomial f of x. Now, is the factor of f of x. Now factorize this polynomial, that is x square plus 2x minus 3. By splitting the middle term, we get it as x square plus 3x minus x minus 3, which is equal to x minus 1 into x minus 3 is equal to 0. And here, two factors, we get two factors, x minus 1 and x minus 3. If x square plus 2x plus 3 is the factor of f of x, then this will be also the factor of f of x, is it? So this is also the factor of f of x. Okay, so if x square plus 2x plus 2x minus 3 is a factor of f of x, then its factors x minus 1 and x minus 3 is also the factor of f of x. So x minus 1 and x plus 3 is a factor of f of x. So x minus 1 and x plus 3 is the factor of f of x. So we get two values for x. X is equal to 1 and x is equal to minus 3. That is f of 1 is equal to 0 and f of minus 3 is equal to 0. So first we have to find f of 1. F of 1, put 1 in equation 1. Okay. Put x is equal to 1 in equation 1. Okay. So 1 raised to 4 plus 6, 1 cube plus 2a into 1 square plus b into 1 minus 3a is equal to 0. So from that we get 1 plus 6 plus 2a plus b minus 3a is equal to 0. Okay. 3a is equal to 0. And from that we get b minus a is equal to minus 7. So equation 2. B minus a is equal to minus 7. Then put x is equal to minus 3 in equation 1. That is f of minus 3 is equal to minus 3 raised to 4 plus 6 into minus 3 cube plus 2a into minus 3 square plus b into minus 3 minus 3 into a. And we get the answer as 81 minus 162 plus 18a minus 3b minus 3a is equal to 0. And then we can rearrange it and we get 15a minus 3b is equal to 81. So dividing throughout by 3, we get 5a minus b is equal to 27. Okay, so this is equation 3. And by adding equation 2 plus equation 3, that is b minus a is equal to minus 7 plus minus b plus 5a is equal to 27. We get the term b got cancelled and minus a plus 5a is equal to minus 7 plus 27. And 4a is equal to 20 and a is equal to 20 by 4, which is equal to 5. And put a in equation 2 because 2 is the small equation. So b minus 5 is equal to minus 7 and b is equal to minus 7 plus 5, which is equal to minus 2. That is a is equal to 5 and b is equal to minus 2. Okay, clear? Any doubts? And able? Okay, fine, very good. Able for our last question for the, that is, usually we have the explanation a minus b the whole square is equal to a square minus 2ab plus b square. And when we rearrange it as a square plus b square minus 2ab. And look at this. Here we expand this a square plus b square again and we get a plus b the whole square minus 2ab. Then minus this 2ab. And finally we get a plus b the whole square minus 4ab. Okay, that's why we explain a minus b the whole square as, that is here. Able, are you there? Okay, here we get alpha minus beta is equal to alpha plus beta the whole square minus 4 alpha beta. Okay, but good. Any doubts? Anybody? Any doubts from any of the questions? So hope you all understand all questions. So just summarize today's revision class consists of the concepts, the basic concept of polynomial, and we studied the zeros of the polynomial, and we all also study the graphical representation of linear and quadratic polynomial and the relationship between zeros and coefficient of polynomial. And zeros of the linear polynomial is sorry, for ax plus b, that is minus b by a. And for quadratic polynomial, that is sum of the zeros alpha plus beta is minus b by a and product of the zeros alpha beta is c by a. So for cubic polynomial, alpha plus beta plus gamma is minus b by a. Alpha beta plus beta gamma plus gamma alpha is c by a and alpha beta gamma is d by a. Okay, so hope you all understand the problems that we done today. And if you have any doubt, you can ask me on the next session. Okay, thank you and good night. Okay, sir. Thank you. Thank you, Sandevi. Bye, good night.